For a long time, the solar system looked like the most familiar part of the universe. The inner planets were rocky. The outer planets were giant. Moons were supposed to be cold leftovers. Asteroids were rubble. Comets were dirty snowballs. It looked orderly, almost predictable. Then the data got better. And suddenly, the solar system stopped behaving like a finished classroom diagram and started looking like a collection of worlds that were never meant to feel this strange. Scientists found a moon with rivers, lakes, and seas, but not made of water. They found a tiny icy world blasting a hidden ocean into space. They found possible ice volcanoes on a frozen dwarf planet at the edge of the sun's reach. They found giant storms and persistent chaos on Jupiter and its moons. And in one of the strangest developments of all, they found an object moving through our solar system that did not belong here at all. That is the deeper story of modern planetary science. The more closely we study our own neighborhood, the less ordinary it becomes. The solar system is not a quiet collection of dead rocks and familiar planets. It is a place of methane seas, buried oceans, cryovolcanoes, extreme storms, and visitors from interstellar space. The strangest discoveries are not all far away in distant exoplanet systems. Some of them are orbiting the same sun as Earth right now. Titan, the moon with seas that shouldn't exist. One of the strangest places in the solar system is Saturn's moon Titan. NASA says Titan is the only world besides Earth known to have liquid on its surface. And yet those rivers, lakes, and seas are not made of water. And they are made of liquid methane and ethane. That means Titan has something eerily similar to weather, drainage, shorelines, and surface liquid cycles. But built from chemistry that would be impossible under Earth conditions. This matters because Titan breaks one of the oldest assumptions people carry into planetary science. We tend to think Earth-like landscapes require Earth-like ingredients. Titan proves otherwise. NASA's Titan Facts page describes rivers, lakes, and seas of liquid methane and ethane, while also noting evidence for a global ocean of liquid water beneath the moon's icy crust. In other words, Titan may contain two separate layers of strange at once. Hydrocarbon seas on the surface and a hidden water ocean below. That makes Titan feel almost impossible. A moon wrapped in haze, on with hydrocarbon weather above and a buried ocean below, is not just unusual. It is a reminder that the solar system can imitate Earth's patterns while using entirely different materials to do it. Enceladus, the small moon with a secret ocean. If Titan is strange because it looks like the wrong version of Earth, Enceladus is strange because it should have been too small to matter. Instead, it turned out to be one of the most important ocean worlds in the solar system. NASA says Enceladus hides a global ocean of salty liquid water beneath its crust, and that jets of icy particles and water vapor erupt continuously from its south polar region into space. More than 90% of the plume material is water vapor, and Cassini showed that the moon is actively venting material from its interior. That is already extraordinary, but the real shock is what it implies. A small icy moon orbiting Saturn is not supposed to be geologically dramatic in the present tense. Yet Enceladus is not frozen shut. It is active. It is spraying material into space. And NASA has explicitly described it as one of the best places beyond Earth to search for conditions suitable for life. This changes how scientists think about where life might exist. For decades, the search focused heavily on surfaces warmed by sunlight. Enceladus forced a different possibility into the center of the conversation: that a dark ocean beneath ice, powered by internal heat and chemistry, may be one of the most promising habitats in the solar system. Pluto, the frozen world that may have ice volcanoes. Pluto used to be treated as a distant afterthought, a frozen relic at the edge of the solar system. Then New Horizons arrived and ruined that simple story. NASA says Right Mons on Pluto is about 90 miles, or 150 kilometers, across and about 2.5 miles, or 4 kilometers, high, and that if it is in fact a cryovolcano, it would be the largest such feature discovered in the outer solar system. The New Horizons team has also pointed to another candidate, Picard Mons, as part of the same broader mystery. An ice volcano sounds contradictory, but on Pluto, cryovolcanism means cold materials such as water ice and other volatile mixtures behaving in a role somewhat like molten rock does on warmer worlds. That means Pluto may not just be preserving an ancient frozen surface. It may have experienced internal processes capable of pushing material upward in geologically significant ways. And this is one of the recurring patterns in solar system discovery. The farther out we go, the less geologically dead the outer worlds look. Pluto was supposed to be quiet. Instead, it may have giant cryovolcanic structures large enough to dominate parts of its landscape. Jupiter and its system, a factory of strangeness. Jupiter itself is not merely large. NASA says Juno has been exploring Jupiter, its moons, and rings since 2016, gathering breakthrough science and imagery. That mission has shown that Jupiter is not just a striped gas giant with a famous red storm. It is a system with violent atmospheric complexity, powerful radiation, deep weather structures, and moons that behave like independent worlds. One of the strangest examples is Io. Voyager first revealed active volcanism there, and NASA's Voyager timeline notes that multiple Io volcanoes were still erupting when Voyager 2 passed after Voyager 1, proving that the activity was ongoing rather than a one-time shock. More recently, Juno has shown that Io remains one of the most extreme worlds in the solar system. This matters because Io should feel impossible on instinct. It is a moon constantly deformed by Jupiter's gravity, heated from within, and resurfaced by volcanism so intense that it makes Earth's volcanic activity feel almost restrained by comparison. In the Jupiter system, even moons are not calm. They are being forced, heated, and transformed by the giant planet around them. Even asteroids can have their own little systems. Asteroids are often imagined as simple fragments, leftover debris, drifting and broken. But some of them turned out to have companions of their own. NASA's Didymos page describes the Didymos-Dimorphos system as a binary asteroid system, where a smaller body orbits a larger one. That means even an asteroid can possess something like a moon, turning a space rock into a miniature gravitational system. This sounds like a small detail, but it changes how we think about the building blocks of the solar system. Not every small object is a lonely shard. Some are dynamic systems shaped by collisions, gravity, and orbital history. That is exactly why the DART mission was so important. It did not just hit an asteroid, it changed the orbit of a moonlet around another asteroid, proving that even small body systems can be studied and altered with remarkable precision. So once again, the strange thing is not merely the object itself, and it is the realization that the solar system is full of complexity even at scales we once thought were simple. Then scientists found something that didn't belong here at all. And finally, perhaps the strangest discovery of all, an object from another star system passing through our own. NASA says Comet 3 I/Atlas is the third known interstellar object discovered passing through our solar system. Scientists categorized it as interstellar because of the hyperbolic shape of its orbit. It is not gravitationally bound to the Sun, and when its path is traced backward, it clearly originates from outside our solar system. That is an extraordinary sentence to say out loud. An object formed around another star, traveled through interstellar space, and entered our celestial neighborhood. It is not permanent. It is not local. It is a visitor. NASA's recent updates on 3I/Atlas make it clear that the object has been observed by multiple missions and that the scientific value of studying it is immense, precisely because it carries information from beyond our own planetary system. This may be the discovery that most powerfully reframes the solar system. We often picture it as a sealed family of worlds orbiting in isolation. Interstellar visitors prove that it is not fully sealed at all. Occasionally, the galaxy sends something through. And when it does, our solar system becomes not just a home, but a crossroads. The bigger truth: the solar system is stranger than the fiction we grew up with. What ties all of these discoveries together is not just that they are weird. It is that they challenge the old categories people used to organize the solar system. A moon can have seas, but not of water. A tiny icy world can vent a hidden ocean into space. A frozen dwarf planet can have possible giant ice volcanoes. A moon can be more volcanically intense than any planet we know. An asteroid can have its own moon. And an object from another star can pass through our system as if cosmic borders do not really exist. The old solar system was neat because it was under-observed. The real solar system is messy, active, and imaginative in ways early astronomy could not have predicted. That is the real meaning of scientists found something strange in the solar system. It is not one object, it is a pattern. The deeper we look, the more our own neighborhood starts to feel as surprising as any distant exoplanet system. The most familiar place may still be the most unsettling. We like to think the greatest mysteries are the ones far beyond our reach. The distant galaxies, the black holes, the planets around other stars. But some of the strangest discoveries in astronomy have come from the place we thought we already understood. Scientists found something strange in the solar system because the solar system itself is strange. Titan's methane seas, Enceladus's plumes, Pluto's possible cryovolcanoes, Io's violent activity, binary asteroids, and interstellar visitors all point to the same deeper truth. Our own cosmic neighborhood is not ordinary. It is one of the most creative places nature has ever shown us. And the most unsettling part is this: we are still finding out just how weird home really is.